Alright, if you have any question like this and you are asked to use Quine Mc Cluskey to solve it, the first step, the first thing you need to do is to convert all these numbers here, each one of them, to their binary equivalents, or to yes, to their respective binary equivalents. Now, first thing you need to do, just draw a binary table for 4 entries w, x, y, z, or 4 inputs w, x, y, z. Now let's do that now. Okay, after drawing your table, the next thing to do is to write out the numbers given to you, starting from 0 to 15. 0, 5, 6, 7, 9, 10, 13, 14, and 15, right? Now, you now find their binary equivalent. Binary equivalent of 0 will be 0, 0, 0, 0, right? Yeah, okay. You can just write this out here. 8, 4, 2, 1. Now, with this number, you use this number to share each one of them. Now, what can you add together here that will give you 5? What can you add together among 8, 4, 2, 1 that will give you 5? Now let's go. You can add, you can add 4 and 1, right? That means 8 is bigger than 5. 2 is 8 is bigger than 5, and 2 also we don't need 2. Since we don't need 8 and 2, you make them 0. We need 4, turn it to 1. We don't need 2, you turn it to what? 0. Okay, we need 1. Right, it's 1 here. Okay, now for 6 we need 4 and 2. 8 and 1 is not are not needed. Just write 0, 1, 1 is 0. Okay, yeah, 0. For 7 we need 4, 2, 1. Okay, we need 4, 2, 1 for 7. Just write 0 here, 1, 1, 1. That's what we do for everything. Alright, this will be our final answer for the table, or final conversion or numbers after this will be the what you call the binary equivalent for all this number. For 0 is 0, for 5 is this, for 6 is this, until 15. Yeah, the next step now is to find your midterm. Midterm simply means those one that has the same the same numbers of 1, or the same numbers of I, and the same numbers of low. Like let's for example, like if we look at 5 and 6, they have the same numbers of 1, right? This one has how many 1? 1, 1, right? 2 of 1. How many 1 can you find here? 1, 2, right? 1, 2. For 7 has 1, 2, 3 of 1. You leave 7 out. We find another one that has the same numbers of 1. Okay. Like this 9, that's numbers of 9. How many 9? How many 1 here? 2. 1, 2. Okay. Alright, how many is 1 here for the first one? Do we have any 1 there? No. Just leave it like that. Now here, how many 1 do we have? 2. Just here. 2 of 1. For this one we have 2. For this one we have 3. 1, 2, 3. For this one we have how many 1? 2, 1. 1, 2, right? Right? 2. For this one, how many 1 do you have? 2 again. For this one we have 3. For this one we have how many 1? 3. For this one, how many 1? We have 4. Now, the next one is, the next step is to gather or group all those one with 2 together and those one with 3 together, and the 4 you leave it out. Now let's check. We have this one, right? How many? 1, 2, 3, 4. Now the 3, sorry, for here we have how many 2, how many 1 do we have here? 2. You group them together, 1, 2. Those one with 2 twos of 2 ones, you group them together, like this one, this one, this one, this one, they'll be together. This one too, they'll be together, and you leave 4 out. Now let's draw the table for that. All right, yeah, this is the table again. After the first one, this one, the next table is this. All right, you can check. These are the midterms. Okay, you can now check those one with 2. What we did is just to do what to gather everyone with 2 of 1s, 3 of 1s, and 4 of 1s together. Like the first one here, 1, 2, 3, 4, 5. Okay, they have the same 1, 1, 1, 1, 1, 1, 1. Just line them. Yeah, there's no 1 here. Line it out. Okay. For the next one, we have how many 1 here? 1, 2, 3. 1, 2, 3. 1, 2, 3. Line it again. Now we now check how many 1 do we have here? There's no 0. What we have here is just 0 of 1s. How many 1 do we have here? It's just how many? 1, 2 of 1s. How many 1 do we have here? 3 of 1s. How many 1 do we have here? It will be 4 of 1s. And you can also draw a line from here just to separate this one from here. Just to separate your answers here with your table or your binary. Alright, this line is just showing that what we wrote here or our output here are different from the binary number. Now this is the second step. This next step is to find the what's it called? Yeah, these are midterm, right? The next one is to pair the terms together, the midterms together. You pair them. Those one with what's it called? You check the number of 0 here, or you check the number of 1, and you check numbers of 1 here too. Anyone that has 3 1s, you pair them together. Anyone that have 2 1s, you pair them together. Yeah, that's the next step now. Okay, let's start pairing now. We check from group 1 and group 2. Let's say group 2 and group 1 and group 3. Which one of them has the same entries, like have the same common binary number? Let's check 5 and 7. There's 0 here, right? And there's 0 here. They are common. Good. Okay, 1 1, right? Common. Good. 0 1, no, it's not common. But there's another 1 1 here, right? And since they have the same 3 inputs that are common, that means you can pair the 2 together. You can pair 5 and 7 together. It's 5 and 7. Now let's check again. 0 0, right? The next one is 1 1. Yes, they have the same thing. The next one is let's check 5 0 1. It's not the same. They're not the same. Just say cancel it out. Now the last one is 1 1. The same. Now this is what we do for everything. Let's check again. Let's check 5 and 13. Now there's 0 here, right? There's 1 here. No common factor there. There's 1 here. There's 1 here. Good. That's not 1. There's 0 here. There's 0 here. Good. There's 1 here. There's 1 here. Yeah, that means 5 and 13 has about 3 common factors. 3 different common factors. That means they can be paired together. Let's pair 5 and 13. Now the first one in their column is what? 0 1. That's bad. You cancel it out. Let's check the next one. 1 1. Okay, good. The next one is 0 0. Right? 0 0. Good. Now the next one is 1 1 Okay, 0 0 again. Okay, 1 1. Yeah. They have three things common together. That means they can be paired. And the next one you need to do is check 5 and 14. 5 and 14, let's check. There's 0 1 here, right? 1 1 here, right? Good. 0 1, no. 1 0, no. That means 14. And since they don't have three, their common factor here is how many? Let's check. 1 1, good. 0 1, no. 0 1, no. 1 0, no. They only have two common things together. That means you cannot pair them. It's only when they have three common things together that's the only time you can pair them. Alright, this will be our final answer. We were able to pair 5 and 7 together, 5 and 13, 6 and 7, 6 14, 9 13, 10 14, 7 15, 10 13 15, and 14 15. Yeah, see, I made a mistake here. You have to open your eyes very well because this thing is very crazy sometimes. Alright, let's move to the next one. If you have any question, you can send to me on the comment table or the comment platform. Yeah. Oh, hello, please. Sorry, I made a mistake here. The step 3 should be pair the mid terms. Pair the mid terms, not find mid terms pair. Just have to pair the mid terms. The what here. The second rule or how level sorry. Okay, sorry. Yeah, pair the second group here with the third group together. After that, you pair the second group with the third group together. Now, if there's any pair, just like what we did here, you just have to pair them. Like after everything, after we pair this 5 and 7, this is what we got. 5 and 13, 6 and 7 is what we got. And the next one is to pair. We have how many groups now? We have two groups, this one and this one here. Yeah, now the next thing is to pair the two groups together. This is the first group 1 from here, group 1. Now from here to here is group 2, 1 and 2. Now you have to pair this group 1 here from here to this place here, to 10 and 14, group 1, while group 2 is from here to this place. Yeah, I just align this place just because I have to, I needed a line here. That's why I line it like that. Alright, let's go. The next thing to do is just to draw a table. Draw a table like this. Write out your W, X, Y, Z. Then you now pair the two groups, group 1 and group 2. You pair and see if there's any common factor. Now let's do that. Yeah, okay. After pairing the two groups, this is what we have. We pair 5 and 7, 5,7 and 13,15 together. Let's look at 5,7 and 13,15. This one is first group here and the second group here. Now, if you compare this and this together, you see they don't have the same. They don't have a common factor up to 3. Yeah, that one is out. Now let's look at 5 and 17, the second group. 5 7 and 13 15. They have 0 1 out. They have 1 1. Okay, good. X good. 1 1 good. That means we can group them together. Yeah, if you group them together, if you do it very well, this is what you will get. This is what you get. Alright, this will be the final answer. Now we now check the unpaired group. The unpaired group, that's, we have to write out all the unpaired group together. We stopped here just because there's nothing to pair again. We only have just one group. You have to stop there since you have only one group. Just stop. Now you now look for you check. You go back, check the group that were not paired together, or the binary numbers or the column that are not paired together. Let's just check that. Now, if you check this one very well, you will see that we didn't pair the 0 here, this first group. We will not pair it with we will not pair this one to form this group, right? We mark it out. This will be our A. Now check again, out of this one here, which one will not pair to form this group. You see that we will not pair, we will not pair these to form this group, but we pair every other one to form this group. That will be our A. Now we check this group again, which one among them here will not pair to form the third group, which is this. Yeah, that will be our B. Let's check. We didn't pair 9 and 13 to form the fourth table or the third table. Okay, the step 4, yes, it would not pair this one. This will be our B. And again, we would not pair 10 and 14 to form this table. We check very well. There's no 9 here, right? And there's no 9, 13. There's no 10, 14. Yeah. Okay, therefore, 10, 14 will be our C. Now, we've gotten our A, B, C. We now check here again. Since we stop here and we not pair these guys to form another table, you stop here. You now say, you compare this and this together if they are the same. Yeah, check. Now, you find out that this guy and this guy are the same. This group with this group, they are the same. I mean, this group 1 1 XX 1 1. Since they are the same, you can call them E. Okay, sorry, A B C D. Okay, we can call it D. Now check this one again. X X 1 1 1 1 XX. Wow. Okay, they are the same too. You can call it E. That means we have A, B, C, D, and E, right? All right, let's check our question again. Now the question says we should find, using the tabulation method, Quine Mc Cluskey, enumerate the steps you will follow in obtaining the minimized standard form. We've gotten our minimized standard form. The next thing to do is to add everything we got out. Now let's add all the unpair together. Now f of w, x, y, z be equal to a plus b plus c plus d plus e. Now check for a. What's our a? Our a is when all the x, w, x, y, z are 0. Check. This is our a, right? They are all 0. W is 0, x is 0, y is 0, z is 0, right? Just have to write that. Just say W, X, Y, Z, bar, because they are all 0. Now say plus B. What's our B? And let's check for B. B is W is 1, okay. X is X, that means X will be out. We take X out. Now we have Y to be 1 and Z to be 1. Good. Just write W. Don't forget our X is out. Yes, because X is what's it called? This is our X, right? Sorry. This is our B. Sorry. Okay, this is our B. Our X is out because of this sign, meaning it's not existing. X is not existing. You take it out. We left with Y. Y bar, because Y, we are writing Y bar. Okay, Z. Okay, we wrote Y bar here because Y is 0. Okay, plus C, our C. Yeah, our W is our D is W, Y, Z. Yeah, Z is, our X is not available just because X is what is X. And once you see that, it means X is out of that equation. This one too is X Z, right? Yeah, no X, no WY, and the last one here, no WX again. Let's check again. Okay, you can see here. Yeah, from here we don't have W is out, X is 1, Okay, y is 1, z is what? Out. Yeah, this will be our last expression. You stop here, and if you stop here, you get your total mark. All right, goodbye.